All right, so I've had a request come through. We're after questions J, K, L, and M from exercise 15A. And they've all got pretty much the same trick in them. And once you see it, you'll understand what you need to do. But let's just go through them anyway. So let's have a look at J. I've got f of x equals 3x take 6 all divided by x. Now, many of you will be tempted. We've done the quotient rule. You could jump in and use your quotient rule here and you'd be right. You get it correct. There is a faster way, but let's have a look at the quotient rule. Just make sure we could do that, seeing as we only learnt it the other day. We're going to say let the top bit equal u, so let u equal 3x take 6, and v is going to equal x. Therefore, we find the derivative of each part. So u dash, or du dx, whichever way you want to write it, is going to be the derivative of this. Well, that's a constant, so its derivative 0. And the derivative of 3x is just 3. Here I've got v. What's the derivative of v? Well, that's x to the power of 1. So it becomes 1x to the power of 0, which is 1. So it's just 1. And what else do we need for our quotient rule? We need v squared. And of course, v squared is x squared. F dash of x, what is it? It's u dash v minus u v dash over v squared. So I fill in the blanks and we'll have our answer. It's going to be 3 times v, which is x, minus u dash is 3, u, which is 3x take 6. Got to make sure I get the right bit in there. Multiplied by v dash, which is 1. All divided by v squared, which in this case is x squared. If we simplify that, I'm going to have, well, multiplying by 1 isn't going to change anything, so we can get rid of that. 3x minus 3x will disappear, and negative 6 becomes positive 6 over x squared. And that would be my derivative. Now, I promised you there was an easier way. Let's have a look if we do it the other way. Oh, that helps if I get my parentheses facing the right way, doesn't it? So we've got f of x equals 3x over x minus 6 over x. Now, being able to separate the fraction into its two parts is a really useful skill, but you've got to be careful. When the denominator is one term, I'm allowed to split it like that. If this was the reciprocal, if it was x over 3x take 6, I could not write x over 3x minus x over 6. Doesn't work that way. It only works if your denominator is one term. Now I can simplify each of these parts before I go. So x and x are going to cancel. That's just going to be 3 minus 6x to the negative 1. And you can see how much faster this is going to be, because now when I do the derivative of 3 is nothing. To do the derivative of the second term, negative 1 by negative 6 becomes positive 6x, and we take 1 away from the power, negative 2. And of course, 6x to the power of negative 2 is the same as 6 on x squared. And we can see that we got it right. That would be my recommended way. Do it the same way for all the others and you can't go wrong. Let's have a look at M just to make sure that I'll leave you a couple to do, but you've actually had a chance to see a couple as well. So f of x equals x cubed plus x take 3, all divided by x. What am I going to do? I'm going to write each one over x. So x cubed divided by x is x squared, x divided by x is 1, and negative 3 divided by x is negative 3, x to the negative 1. It's still f of x at this stage, and we say therefore f dash of x, and we do the derivative. Derivative of x squared is 2x. The derivative of a constant is 0, because it's not changing, it's constant. And finally, the derivative of the end term, negative 3 by negative 1 becomes positive 3. Subtract 1 away from the power. That's your answer, 2x plus 3 times x to the negative 2. Of course, you could write it as 2x plus 3 over x squared, but either of those are going to be acceptable. I hope that helps. Have a go at the other two, make sure you get them right, and we'll see you in class. Cheers.